Alright, hello everyone, welcome back. So in today's lecture, we will plan to provide you with a midterm overview for you. So today is easier for you because we don't have much materials to be covered in today's lecture. It is also super easy for me because I only need to record one single video covering the materials we have discussed already. Okay, so let's talk about the midterm we plan to take in this week. Okay, so the time for the midterm will be on this Thursday. We will release the question for the midterm by the end of this Wednesday midnight. Then I can give you about 24 hours to finish the midterm, and you need to submit the answers to Canvas system by the midnight of Thursday. And we will have no class on this Thursday, so I think you should have enough time to finish all the questions in the midterm. So midterm will be a take-home exam, and the answers will be uploaded as one single PDF document to Canvas system, so TA can grade it for you. And the midterm will be based on individual work, no discussion will be allowed, and no QA will be provided during the midterm from the teaching staff, so you cannot ask a question to me or to the TAs during the exam time. And any form of cheating on the exam will be resulting in 0 grade, and also we will report this case to the university. So if you observe anyone cheating during the exam, please let me know, and you can also get some bonus if the cases are confirmed. Originally, we plan to make this midterm as a closed book, closed note. However, according to the email from some of the students, this kind of policy will probably hurt the honest students because some of the students will not follow the rules. Then, according to the feedback from students, I will decide to make this exam, midterm exam, as open book, open notes. So you can check the textbook, also the slides and reading materials during the exam, and to finish all the questions. So the time is 24 hours, and you should have enough time to finish all the questions. So please remember to schedule your time well. So no makeup exams or the extensions will be provided for the midterm actually. Okay, so to prepare for the midterm, I think it's time for you to review what we have covered from this course already. And the midterm will be about 10% of your final score. And the topics covered in the midterm will be accumulative. So all the materials we teach in the class as well on the textbook, all the reading materials will be covered in the midterm, except this VAE model. We talk about them in the auto encoder section. So specifically, we will cover all the topics starting from the introduction to the machine learning basics, to the optimization, to deep learning basics, auto encoder, CNN, computer vision, as well as the game model. They will all be covered in the midterm. As to the question formats, it will be very similar to the homework one, and we will have several different categories of questions in the midterm. We will have questions on true and false questions with brief explanations. So for example, we show some question here, like a large learning rates, we always need to fast convergence. Is it true or not? Also, we have some example like a CNN can only handle image data inputs. Is it true or not? We also have some short answer question like what is the advantage of memento compared with vanilla gradient descent? Why we need to consider memento, right? For example, you need to provide some short answers to such questions. We also have some questions on calculations. We will provide you some of the questions like this. You need to calculate some numbers or some equations according to the question. Of course, we will also have several more questions we will provide in the midterm. The midterm will be 100 points, and it takes about 10% of your final grade for this course. And I believe you should have enough time to finish all the questions within 24 hours. So no extension, no makeup exam will be provided for the course, for midterm. So I have some suggestions for you to prepare for the midterm. Please go over all the lecture slides as well as recording lectures if you didn't attend the class, and also start the textbook, reading materials. And try to work independently on problems in the homework, in the lecture, as well as exercise in the textbook. Also discuss with people in the class, and you can contact me as well as the TAs if you have any questions. Please do some practice before the midterm and work on some questions before looking at the solutions. These are the suggestions I have in my mind for you to help you prepare for the midterm. So I think it's also time for us to go over what we have covered already for this course. Actually, we have covered a lot already, for the course. So in this page, we'll show you the organization of the topics covered in this course. So we have 5 main sections covered in this course. In the very beginning, we'll talk about some background knowledge for you about deep learning. In the very beginning, we discussed about the introduction of deep learning as well as the machine learning basics and the optimization techniques we can have, right? Then we talk about the deep learning preliminary knowledge, which covers the deep learning basics, the multi-layer perception as well as autoencoder. And after that, we talk about deep learning for the image processing, right? If you still remember, we have talked about the CEM model, the computer vision problems, as well as this GAN model, right? So after the midterm, we still have 2 more sections to be discussed in this course, like deep learning for text, as well as deep learning for graph. So we will discuss something more about them in the following lectures after the midterm. So here I'd like to add something more. For the models, even though we say like CEM, it is a deep learning for images, actually beyond the images, so the CEM model can also be applied to deal with text data as well as graph data. It will be similar for the recurrent neural nets. Besides applying them for dealing with the text, some people also extend recurrent neural nets to deal with the images as well as graph data as well. So we cannot say one model can only deal with one category of data. Actually, they are very flexible. We can do some extensions to them and make them to handle some other data as well. Right. Okay, so you can see from these 5 sections we have like several models which I highlighted. We also highlight some of the models like MLP, CEN, recurrent neural nets, and GN, right? So we highlight them because, we have one project in this course, right? You can see, generally from each of the sections, main sections, we select one model and to ask you to implement them in your project, right? So if you still remember, we provided you with this page before, about projects in this course. So besides stage 1 on the environment setups, we have 4 main stages, for the project. The stage 2 is on the MLP and apply them to classify some data inputs, right? So we plan to use stage 2 to warm you up to the coding with deep learning. And after that, we move to the stage 3, which is on the CEM model. And we're going to ask you to write something new on CEM to classify the images, right? And in the stage 4, we will do the text instead. We will try to build a recurrent neural net to either classify the text inputs or generate the text instead. And finally, in stage 5, we'll play with the graph data instead, and we try to build some graph neural nets to do both network embedding as well as neural classifications. So you can see the project actually corresponding to the 4 main sections about the course, right? On the preliminary knowledge, the deep learning for images, deep learning for text, and deep learning for graphs. So by providing with the organization of topics, I hope you have a big picture about the topics covered in this course, as well as the current research about deep learning. Of course, besides these main sections shown in this page, the deep learning is a very broad area. We can also start deep learning for many other sections, many other topics as well, which are beyond this course, and you can further explore them more by yourself in the future after taking this course. Next, we can provide you with an overview about the topics covered in this course. So if you still remember, we have several sections about background knowledge actually. We have one section on the introduction for the course as well as deep learning. So we talk about deep learning current and future development. We talk about the applications of deep learning as well as the market of deep learning in the future years. And we also discuss the industry and academic achievements about deep learning in the past years. Then in the section 2, we talk about the basics of machine learning for you, which is to provide you with some background knowledge about machine learning. We talk about what is machine learning. Then we discuss about the supervised learning. It covers both the classification and regression, right? We talk about how to split the training set, testing set, right? As well as what is the SVM model. And after that, we talk about the regression. We mentioned 3 basic regression models, like linear regression, ridge regression, and lasso regression. We also talk about how to add the organization terms to the objective function of these regression models, right? Especially for the ridge and lasso. And then we discuss about the clustering problems. We discuss what is the difference of this unsupervised learning versus supervised learning, and how to do the clustering. We mentioned one of the algorithms in the clustering is a part about k-means, right? And how to use the k-means to clustering the data instances and into different groups. And at the end of this section, we discuss about the evaluation metrics used for classification, regression, and the clustering, right? And some of these evaluation metrics, I think they have been used in your projects already, like for the accuracy, F1, precision, recall, they have all been used in your projects already, I think, right? Another kind of background knowledge is about optimization. We discuss how to optimize some of the models by minimizing or maximizing the object functions, right? Which will be used for the deep learning model training in this course. I think you have also been playing with some of the optimizers in your project, like Adam, like SGD. I think some of you also use this mini batch for the optimization as well in your project already. Then it will be very good, right? I think by using them in your projects, then you can learn and also understand this kind of algorithms much deeper, right? So there are several key factors in optimizing your models. So first of all, the data perspective, what is your input? Depending on the size of your input as well as the memory of your machine, you need to decide use the full batch, the instances, or the mini batch, right? Also depending on your output, which will be either real values or probability distribution among different classes, you can decide your loss functions, right? Like the MSE or the cross entropy as your loss function. Of course, you also have to design your models, which will be a mapping, right? Mapping the inputs to the outputs. You also need to initialize your variables to be learned. Of course, you also need to decide your optimizers. Like you need to choose among different optimizers, for your projects and for your model. Now the GD, the momentum, the adaptive gradient, as well as the Adam, right? You also need to specify some parameters inside your optimizer, like the learning rate, as well as some other parameters. This is the introduction section to prepare you for the course about the background knowledge. And after that, we'll talk about some preliminary knowledge about deep learning. If you still remember, we have one section on the deep learning basics, right? And we have also talked about one model, it's called MLP, the multi-layer perception. And to train the models, we discuss this error backpropagation algorithm, right? And which will be a very important algorithm. It will be used in training almost all the deep learning models nowadays. So the error backpropagation algorithm relies on the gradient descent algorithm, of course. They will use some optimizers to updating the variables. However, in the error propagation algorithm, they will utilize some of these intermediate results to reduce them, to lower down the time cost, right? So in this way, so by utilizing these intermediate results, we can backpropagate these errors from the output layers to the model layers, right? Other layers inside the model architecture. And after the deep learning basics, we'll talk about another model. It's called autoencoder, right? We mentioned this autoencoder is a very general framework or general architecture. Inside, we have this encoder decoder, right? And which can be defined with different base models. So I hope you still remember, for the deep learning basics, we discussed about the background knowledge. What is deep learning and why we need to have deep learning? We also provide you with a brief history about deep learning and what makes deep learning work. So as to a technical part, we discuss about the artificial neurons as well compared with the biological neurons, right? And based on these artificial neurons, we have developed one simple model. It's called perception. We also discuss its workings in classifying the XO data set, which is a nonlinear, right? So to address the nonlinear separation of the task, then we introduce a multi-layer perception by adding some hidden layers into the model. And we also discuss how to apply the multi-layer perception to classify some image data sets, right? Which is also covered in your project stage 2 already. We discuss how to train an MLP by defining its loss function and first utilize the error propagation algorithm to train a deep learning model with the MLP, right? And after deep learning basics, we talk about the important model. It's called autoencoder. I hope you still remember this section for the autoencoder, and we discussed what is autoencoder, what is the model architecture of autoencoder, and how to train a model, and how to define loss function, of course, right? And if we define loss function as a minimization, the difference between the inputs and the reconstruction outputs, then we can train the model in an unsupervised way because we don't require any label information, right? And we also talk about what can the autoencoder do and what are the advantages, and also what are the potential applications of autoencoders. Besides the vanilla autoencoder, we also discussed some variants of autoencoders, right? If you still remember, in the autoencoder section, we discussed some extensions of autoencoder by incorporating some of the organization terms into the model architecture, right? And we also discussed another model. It's called the variation autoencoder. Actually, this part is optional for you. It's not required to understand these details, and we will not cover them in the midterm exam either. So this variation autoencoder or the VA model is more like a probabilistic graphical model instead. It's very different from the autoencoder we covered before, which is not based on deep learning actually. And we'll discuss why it is also called autoencoder, even though it's not a deep learning at all. And what is the variation autoencoder architecture and learning process. We also mentioned this variation autoencoder learning process via the gradient descent with this reparameterization tricks in the model architecture, right? So this part is very difficult, and we mark this one as optional, and we will not cover them in the midterm actually. So after this preliminary knowledge about deep learning, then we can move to a new section for deep learning for images specifically. If you still remember, we covered 3 sections on this part. We talk about what is CN and computer vision as well as the GAN model, right? So for the CN, this model is very important, and we will have some questions on the CN in the midterm. So please make sure you understand all the details about CN we discussed in the lectures. So inside the CN section, we talk about what is the conventional image processing techniques as well as the mechanism of MLP in processing the images. We will discuss the image processing operators with the convolution operator, and also what is convolution and how to calculate convolution on images. And we also discuss some key parameters to set up for the convolution, like the padding, like stride, as well as kernel size and the channel number, something like that, right? So we also discuss how to calculate the output size based on the inputs as well as these parameters. And after that, we discuss this convolution neural net by incorporating the convolutional layers together with the pooling layers as well as fully connecting layers. We discuss what is a CN model architecture and what is the pooling layer used inside the CN model architecture and how to calculate the results for the pooling layers. We also mentioned several variants of the CN model, like the NXNet, VGG, and the inception models, right? And we also discuss how to make the CN model deeper by utilizing this residual learning. We discussed what is the residual learning and what is ResNet by incorporating some higher ways, connecting different layers. So this is the CN model, this section. And this section is very important. I hope you can go over the lectures, carefully again after class to make sure you understand all the details inside this section. And after that, we provide you with a brief introduction about the computer vision, right? How to use CN models to start some of the computer vision problems. If you still remember, in this section, we discussed what is computer vision, what computer vision is about, and how to represent the images, and also is computer vision hard for human beings and machines, right? And then we discuss some of the potential problems we can start in computer vision, which will be optional for you actually, because we will not cover them in the midterm. If you still remember, in this part we discuss some potential problems we can start in this area, like object detection and localization and segmentation. We will discuss the image classification, style transfer, colorization, super resolution, reconstruction, and synthesis, right? And for some of the problems we mentioned above, we also provide you with some potential solutions proposed by the researchers. Like we can do the colorization as well as do the style transfer, right, with the help of the convolutional neural nets. So for the problems as well as the potential solutions, these two parts will be optional, and we will not cover them in the midterm. And after that, we discuss another very important model. It's called GAN. I hope you still remember the architecture of GAN. Inside the GAN, we have 2 main components, the discriminator as well as the generator, right? In the very beginning of this section, we talk about what is the discriminating model and what is the generative model. What is the main function of these 2 kinds of models, right? For the discriminating model, they try to differentiate the data instances into different categories. However, for the generative model, from its name, we can see it's focused on generating some data instances instead, right? And we provide you with some examples of the discriminating model like MLP and CN, right? And we'll justify why this autoencoder cannot be used as a generative model in many of the applications, and why we have to start the generative model in the GAN instead. And after that, we talk about the more detailed information for the GAN and this model architecture, which will be defined one GAN between the generator and the discriminator. So the main target of the GAN model is to do the generation. However, to help train the generative model inside the GAN model, we incorporate one discriminator, which will be more like a judge, right? They can differentiate the real data from the fake ones. In this way, they try to help the generator train better. So I hope you can understand the roles of the generator and the discriminator. The generator is focused on generating the data instances, however discriminator is more like a judge. They will help each other actually. So we also discussed how to train these two components inside the game iteratively. We can fix one and update the other one, right? Iteratively until convergence, until we can reach the stationary state. And we also provide with some examples what the game can do, right? By generating some of the image examples, right? So this section is also very important. I hope you can understand the roles of this generator and discriminator inside this game model and also how to train them. So you can see, by finishing half of this course, we have provided with the introduction to many of the important models already, like MLP, autoencoder, CN, and again, we will teach you how to train them, right, by covering one section on machine learning basics and with the optimization. So by doing the two project stages, with the MLP and the CN, I hope you have some feelings now about deep learning and how to play with them, right? So you find that the deep learning is very different from other areas, like from machine learning, right? I still remember at the very beginning of this course, I received an email from students asking what's the difference of this course compared with machine learning. Now I think you can see the difference, right? So this course is a very different style compared with machine learning. We focus on specific models about deep learning instead. We discuss some specific model which can be used to deal with different kinds of data about deep learning, right? So by doing the projects, I hope you can learn something useful from the course. Also, which will also help you to get prepared for your future career as well as future research. And after you finish the midterm, you can take a break and you can also get relaxed for a while. I think for this course, it's very tough. It's also very difficult for you in some sense, because before, normally I teach this course in one semester. In other words, I can arrange everything into 16 weeks, but now I have to teach everything in only 10 weeks in one quarter, right? So you can see we have so many deadlines for this course. I can understand from your perspective, right? I think it is very tough for you, especially if you have never learned something like this before. It will be very difficult for you. But I really hope, after you're finishing all the projects or the homeworks, you can learn something useful from this course. This is very important, right? Because you pay the tuition, you pay the money to take the courses, then I really hope you can learn something useful from them, right? So from this course, you can see the organization of different topics, also the organization of the projects. We generally want to get you prepared for different kinds of topics about deep learning. No matter what kinds of data you plan to deal with or handle in the future, then you can learn something useful from this course to get you prepared, right? Okay, so generally that's it for this section. So after today's class, you need to prepare for the midterm. I hope you can go over the lectures again carefully, especially for several important sections, right? And many of the questions we cover in the midterm will be from these sections actually. Okay, so if you have any question for this section, for midterm, then you can ask me either during my office hours. Of course, if you prefer to talk with the TAs, you can also ask them during their office hours as well. I hope you will be doing good for the midterm, and I will send you the email with the detailed instruction as well as the question for the midterm by the end of Wednesday. So remember, finish it on Thursday and submit the answer to the Canvas system by the midnight of Thursday. So that's it for this section, and thanks a lot for your time and attention.